Hey all, welcome back to one more session today. In today's session, we are going to talk about APB protocol. Since many of you are requesting me in LinkedIn and in my Telegram channel to start the APB protocol series, so which is why, as for your request, I am making these videos on APB protocol. Okay, after completing this APB protocol, I'll resume my system verilog sessions. I have completed until oops in my system verilog, and the next concept in my system verilog is randomization. So stay tuned for that. And as for now, we are going to talk about APB protocol. Okay, hope it is useful for at least some of you who are interested in learning about APB protocol, right? So before going into APB protocol, if you are new to this session, please consider subscribing this channel and hit the notification bell also follow me on all my social media handles to get regular updates, right? So now coming to APB. APB protocol is nothing but Advanced Peripheral Bus Protocol. Okay, so this protocol, like this APB protocol, is a part of Amba family protocols. Okay, so in this APB protocol, we are going to see all these things. Like we are going to see what is Amba protocol, and then Amba evolution, and within Amba architecture, how we use this APB protocol, and then we are going to see the introduction of APB protocol, and then what are the signals that we are having in this APB protocol, and then how the communication between master and slave will be happening in this, and then the state diagram and the timing diagrams within the APB protocol. So all these are the things that we are going to cover in this sessions of APB protocol. Right now, coming to introduction of Amba protocol. So, as I told you, APB protocol is the family of this Amba protocol. Amba protocol is nothing but Advanced Microcontroller Bus Architecture Protocol. Actually, this Amba protocol was introduced by ARM, okay, Advanced Risk Machine, in 1996. Okay, so why I'm telling it APB is the part of Amba protocol is because in Amba protocol, we are having many other protocols like APB, AHB, AXI, ASB, etc. So among all this, APB is one of the protocol. Okay, basically Amba is a set of interconnect protocols. Basically, we are having two kinds of protocols which are interconnect protocols and communication protocols, within which Amba consists of all interconnect protocols like APB, HBXA, all these are interconnect protocols. Okay. So basically, what is the reason behind introducing APB is that APB is primarily introduced in order to provide simple and efficient way, okay, in order to connect low speed peripheral devices, like for example, you see this mouse, keypad, so all these are low speed peripheral devices. So in order to interconnect these particular low speed peripheral devices to the processors in the SoC, APB was introduced. Okay, this is about APB. Now coming to the evolution of Amba protocol, like when it was introduced and what are the versions that were actually there in this Amba. So, as I told you, it was introduced in 1995. So, during its introduction, there are only two kinds of protocols which are APB and ASB. Okay, for high speed, we go for ASB protocols, and for low speed, APB was introduced, low speed peripheral devices. Okay, later on in 1999, AHB was introduced, like AHB, AHB Lite. Okay, so along with this, APB is also revised from APB to APB2. Okay, APB protocol is revised in 1999. In Amba 2, you will have the revised version of APB. But during this revised version, there are no much changes made during this revision of APB 2. Basically, in APB and APB 2 also, you will find when you see the spec of APB and APB 2, you don't see much changes among anything. Okay, now in Amba 3, like in 2003, along with AHB, AXI 3 was introduced, and along with this AXI 3, the APB2 was revised into APB version 1.0. Okay, basically, when you see any protocols, much mostly when you see any explanations in protocols, also mostly you see this version, that is APB v1.0. Okay, when you see the when you download the spec from basically this APB protocol is a open source, so you can download it directly when you go to the ARM website. Okay, so when you download it, in the introduction you will see this version, like whether it is APB2 or APB v1.0 or APB v2.0. Okay, v1 means version 10. Okay, 1.0. So in this APB version 1.1, actually the APB consists of 8 signals. Okay, so in both APB and APB2 also there are only 8 signals. But when it comes to APB version 1.0, two more signals were introduced. So total there are 10 signals in APB version 1.0. So what are the signals that were introduced in APB version 1.10 is that P ready and P slave error. Okay, we'll talk about this later, but these two were introduced in version 1.0. So basically these are wait transfer error response signals. Okay, so these two were introduced in APB version 1.0, and later when it is re-revised in version 2.0, another two signals are introduced in version 2.0. So in APB there are 8, in APB and APB2 also there are 8 signals, whereas in APB version 1.0 there are 10 signals, and APB version 2.0 there are 12 signals in total. Okay, so what are the two more signals that were introduced in the version 2.0? They are P protect and P strobe. So these two signals were introduced in version 2.0 in APB. So basically these are transaction protection and sparse data transfer signals. Okay, so these two signals were introduced in version 2.0. So this is how the evolution in APB took place. Okay, until 2010. Basically we at present we are using only this version 2.0 itself. Okay, so this is about APB, right? So these are the total signals in APB. So presently if you are seeing the version 2.0, there were total 12 signals in this APB version 2.0. Okay, so don't get confused if you see only 8 signals in APB. That may be because you are reading this APB version, APB original version, or the first version of APB. Okay, if there are 10 signals, then there is the APB v1.0, and if there are 12 signals, that is APB v2.0. Okay, so this is how the evolution of APB took place. Now let us see the Amba bus architecture. Before going to see what are the things that are there in APB, and what is the need for APB, everything, like what are the key features of APB, everything about APB. Before talking everything about APB, let us make this somewhat interesting. Before learning it, let us know how we are actually using it, like where is the place we are actually using it and what is its need in our Amba bus architecture. Okay, now if you see this architecture here, this is the Amba bus architecture. So here, in any system, the processor is the core of that particular system, is it or not? So in this system also, I am using ARM processor. Okay, so this is high performance ARM processor. So within my system, along with processor, you will be having lot more components, is it or not? Like a RAM, okay, memory, everything. Similarly, in this particular architecture, you see along with ARM processor you are having many other components, like high bandwidth components like RAM, okay, DMA bus master, memory interface. So these all, or if you see, high bandwidth components. Okay, since there are high bandwidth, that means they are high speed, high frequency components. So all these are interconnected. Like if you see, all these are connected to this processor with the help of AHB or ASB. Like ASB, now we are calling it as AXI, basically AHB or ASB bus. Okay, so if you see here, all the components are connected to the processor by using the AHB bus. Okay, since there are high bandwidth devices. Now when it comes to the similarly, every device you'll be having high bandwidth devices as well as low bandwidth devices, is it or not? So just like all the high performance and high bandwidth devices are connected to AHB, similarly low bandwidth devices or low power devices like UART, timer, like keypad, programmable input output devices, just like this among these low bandwidth devices, the most things that you see regularly like mouse, okay, pen drive, so all this will be coming under low bandwidth devices. Okay, so all these low bandwidth devices are connected by using the APB protocol. Got my point? So that is why I told you. So APB is primarily introduced in order to interconnect all the low peripheral devices. That means low bandwidth peripheral devices. Okay. So now if you see here, okay, so as I told you, all low bandwidth or low frequency devices are connected by using APP. All the high bandwidth devices are connected by using either AHB or AXI, any protocol. So, when it comes to interconnection between this high bandwidth and low bandwidth, okay, that means when you want to transfer, like for example, when you are transferring the data from keypad to this processor, okay, so keypad is the low bandwidth or low frequency device, and processor is the high bandwidth device, is it or not? So, in order to make the transfer happen between these two devices, in order to make the transfer from low bandwidth to high bandwidth devices happen, what is there here? There is a bridge in between these two connections. So what will this bridge actually do means, it will convert the low frequency low frequency data that is given by APB to high frequency data. Okay, that means whatever data that the APB is transferring to bridge, it is low frequency data, because APB is the low bandwidth and low frequency device, so it will send only low frequency data. So this low frequency data is converted into high frequency data, and then it is sent to the AHB, through which it is given to the processor. Okay, so that is the use of the bridge here. So in order to make the communication between low frequency and high frequency things happen, the bridge acts as a converter. Okay, it will be converting high frequency to low frequency. Similarly, when a processor wants to send any response, okay, when the ARM processor, when any processor needs to send any response to that keypad or else to anything which is low bandwidth, what it will do, again the bridge will be converting this high bandwidth devices to low bandwidth devices. Okay, so this is how the bridge will be working here. This is how the architecture is happening within this particular thing. Now if you see, now basically this is what happening, we can say. But when you open the motherboard or when you see any processor, all this is done internally. Okay, even though I'm writing all these blocks, you may not see all these blocks within your particular motherboard or within anything. This is a thing that is actually internally done within your particular motherboards or any other things. Okay, so this is about the Amba bus architecture. Now you got an idea on what is this APP protocol and what are the components that come under this APP low bandwidth protocol devices, and what are the components for high bandwidth devices, and what is the use of bridge and all. Right now, coming to the APP protocol. So until now we have seen what about evolution of APP protocol, and then about the architecture of Amba, and what is the use of this APP protocol and all. Now coming to, okay, now coming to the APP protocol. So basically, as I told you, APP protocol is the low performance per protocol. That means since it doesn't need much power consumption, and because of this, it is having many advantages. Like it is a low cost protocol, and then it is mainly used for connecting low peripheral devices. Okay, low bandwidth peripheral devices. So as I already told you, APB is the part of Amba family, and it is reduced interface it is having reduced interface complexity. And also one important thing about APB protocol is it is a non pipeline structure. So since it is non pipeline, it is very simple and it is easy to understand. Okay, there is no much thing needed when you are talking about APB protocol, since it is very simple to understand, and also the designing and verification part is also really simple when it comes to APB protocol. Okay, so in APB protocol, while you, as I told you, while we are talking in bus architecture, everything is about data transfer. Is it or not? The data is to be transferred from one device to one component to another component. That is the thing actually the bus will do. Okay, bus is used to carry, is it or not, it will be carrying the data from one component to another component. So while we are transferring the data in APB protocol by using APB protocol bus, if you are transferring the data, then that transfer, every transfer will be taking 2 cycles to complete. Okay, one is one cycle is called as setup cycle, and another cycle is called as access cycle. So okay, so we'll be talking about this setup cycle and access cycle when we are discussing about the state diagrams. So as for now, it will be use APB protocol will be taking 2 cycles in order to complete one transfer. Okay, and also one important thing is that all the transactions or the transfers that are being done within the APB, so everything will be run during the clock rising edge of the clock cycle. Okay, so every transaction will be, that means only when peak clock is high only the transactions takes place. When the peak clock is low or in the negate, then there won't be any transactions or transfers happening in the APB protocol, right? So this is about the APP protocol introduction. Now coming to what are the key features of APP protocol. As I told you, there are it is very simple and it is the low power protocol. Because of this, as I already told you, in APB you will be connecting only low bandwidth peripheral devices, so it requires only low power. So because of this power efficiency, APB is made an ideal choice for battery operated devices. Okay, and then coming to fixed transfer size, basically the maximum amount of data that we could transfer through APB protocol is of 32 bit. Okay, maximum data that you could transfer with APB protocol is only 32 bit. So basically the size is fixed from to either 8 or 16 or maximum 32. So which is why, since the size of that particular protocol is fixed in size, so which is why it is easy to predict how much amount of data it is being transferred, how much amount of data is being transferred from one component to other component. Okay, now coming to low bandwidth, as I already told you, since we connect only low bandwidth devices, so it is having low bandwidth and high latency. So because of this, since APP protocol is made of low bandwidth for made for low bandwidth devices, mostly you will be connecting components like UARTs, timers, okay, GPIO controllers, so etc. All these types of things only you will be connecting in case of by using this APB protocol. Okay, so these are the key features of APB protocol. Now coming to APB protocol, as I told you, is a crucial component for SOC device. Okay, mostly in order to connect any low component devices, low power devices, we will be using this APB protocol only. Even though we are having many other things, APB is one of the crucial component we will be using mostly when you enter into the real time field. Okay, so there are several reasons for this. Okay, so some among those reasons are peripheral connectivity. That means this provides the standard way to connect and communicate with various peripheral devices. Okay, so within the same system, it will be providing a standard way to communicate between the devices. And then, as I already told you, it is power efficient. Since it takes less power, so we mostly prefer it when you are using any battery powered devices. Okay, when you are using any battery powered devices, you will be going for this APV protocol only because of its low power characteristics. Okay, and then as we already know that it, since it is a non pipeline structure, it is is very easy and simple to understand. And also the developing time and the cost is also very less compared to other peripheral devices, other buses, other protocols like AHP and AXI. Compared to that, APB is really simple to understand as well as to implement and verify, which is why it is because of this also mostly everyone will opt for APB. Okay, and then coming to integration. Integration means nothing but basically, since this is also, as APB is also a part of Amba family, so we can easily make it compatible to any other ARM processors. Okay, that means while using any other ARM processor core, IP core, you since this is also a part of Amba family, we mostly opt for this APB protocol rather than other low speed protocols. There are also many other low speed protocols, but we mostly opt for this APB because of its belonging. It belongs to APB or Amba family. Okay, so this is about the things about APB protocol. Now coming to the signals that are present in APB, as I already told you, in Amba there are revised versions in APB. So now if we are talking about version 2.0, as I told you, it consists of total 12 signals. Okay, so if you see here, these are the signals that we mostly talk about when it comes to the APB or advanced peripheral bus. So if you see here, this is how basically this is our processor, because we have already talked about this in our architecture. So if this is the processor is connected to the bridge by using the high speed protocol like AXA or AHB anything, and from this bridge other lower peripheral protocols like UART, timer, so all this will be connected with the help of APB. Okay, now within this APB there are total 12 signals. So these are total 12 signals: P select, P enable. Now if you see all these signals, they were introduced with P as their initial letter. Why is it? Because since APB, since it is APB, that is why the P bus. For example, if it is AHP, then it is introduced with H letter, like H select, H enable, like that. Since it is a APB, so that is why P select, P enable, P address, P write data, P stroke, P protect, PR data, P ready, and P slave error. So these are the signals that we are going to talk in APB in our sessions, later sessions. So all these signals will be sent by APB master and APB slave. Now talking about APB master and slave here, for example, in this bus architecture, we have already talked about this AHB and APB. Okay, and then the bridge in between them. Now, when we are taking this particular high performance components into consideration, then what happens? Like, for example, if we are taking this ARM processor as our into consideration, then this ARM processor will be becoming the master. That means from processor, whatever it is coming, the ARM processor will be becoming the master, and then the bridge will be considered as slave. When we are taking this high bandwidth components into consideration, then the master will be this high bandwidth components and the slave will be the bridge. Okay, now when we are talking about low bandwidth devices, okay, when we are talking about this particular part, now what happens? All these low bandwidth devices will be considered as slaves, and then the bridge is considered as master here. Okay, so now if we are taking this particular thing into consideration, in this APB master is our bridge. Okay, when we are talking relating this to our Amba architecture, so here APB master is our bridge, and the components like timer, okay, I2C, anything we are considering, we are connecting, those are considered as APB slaves. Okay, so from master to slave there are certain signals, and from slave to master there are certain signals. Now if you see here, whatever signals that are going from master to slave, those are considered as output signals, because master is giving them to slave. So all the signals like P select, P enable, P address, P write data, P strobe, and P protection, all these are output signals. In APB, all these signals that are going from from master to slave, they are considered as output signals. Okay, and then PR data, P ready, and P slave. So these are the signals that master is receiving from slave. Okay, that means the slave is responding and the master is receiving it. So these three signals are the input signals. Okay, because they are receiving to master. So these three are considered as input signals. Okay, and these are all the output signals for APB. Okay, so apart from all this, there are also other two signals, like you already know, that is clock and reset. So these are always, so clock and reset, they are always the input signals. So there are total five input signals, and the remaining all are output signals within this APB protocol, right? So among all these signals, we'll be talking in detail about all these signals in the later session. So as for now, this is about the introduction of APB protocol. And if you like this video, please consider subscribing this channel and also hit on the notification bell. And that is all for today. Thank you.